تأكد الريكوردينج. اوكي طيب. What module 6 talking about? Ether channel. Now let us jump to the main operation of Ether channel, and it will be very clear why we need it here. What's the link aggregation? Grouping multiple links together, simply like this. Now there are a scenario in which more bandwidth or redundancy between the devices is needed than what can be provided by a single link. Now when I talk about a single link, I'm talking about the spanning tree protocol. But I need to improve the bandwidth, so I need more bandwidth or redundancy between the devices, not a single link. So multiple links could be connected between the devices, in this case, to increase the bandwidth. But what's the main problem? Spanning tree protocol, which enabled on layer 2 devices like Cisco switches, will by default what? Block all the redundant links to prevent the switch loop. So this is the main case. I need a redundant link. Spanning tree protocol implemented, so it will only allow for a single link. So what we will do in this case, we'll use a technology or a link aggregation technology. We need a techniques to group all of these physical links into a single logical link. So the spanning tree protocol will consider it as a one logical link, and it will not be blocked. And we will have a redundant links here between the devices. So link aggregation protocol is needed that will allow redundant link between the devices that will not be blocked by the spanning tree protocol. What we call this technology, we call it Ether channel. So Ether channel is a link aggregation technology that will group multiple physical Ethernet links together into single logical link. So, for example, on a switch, I will aggregate or a group together port 1, port 2, port 3, 4, 5, 6, 7 between two switches as a single logical link. So usually it's used to provide fault tolerance. One of them is down, the other all of them up, load balancing or load sharing between the redundant links, increase the bandwidth and the redundancy for sure between the switches, routers, and servers. Now, Ether channel technology makes it possible to combine. We can group multiple physical links between the switches in order to improve the overall speed of a switch-to-switch communication. I'm talking about between switches, between routers, between servers. I did not mention the host at all. Okay? Now, this is the main idea of the Ether channel. Ether channel technology was originally developed by Cisco as a LAN switch-to-switch techniques of grouping multiple fast Ethernet or gigabit Ethernet into one logical channel, one logical link. So when an Ether channel is configured, the result will be a virtual interface called port channel. Once we combine multiple physical links into one logical link, what we call this a port channel. So this is our port channel actually. Port channel. The physical interfaces will be bundled together into a port channel interface as what we see in this figure. So we have two links grouped as a single one, two physical links grouped as a single one port channel interface. Now, what's the advantages of Ethernet or Ether channel? Main advantages: most configuration tasks can be done only on the Ether channel interface, on the port interface, the port channel. So I have 10 ports grouped together. I will only configure the port channel. So most of the configuration task can be done on the Ether channel interface instead of what? Of on each individual port, ensuring the configuration consistency through the link. Now, Ether channel relies on existing port switch. There is no need to upgrade the link to a faster or more expensive connection to have more bandwidth. Just use what we have on the switch. Load balancing takes a place between links, a part of the same Ethernet channel, distribute the load between the redundant links. This is the load balancing initially for this class. Ether channel creates aggregation that is seen as one logical link. This is the main important. We are going to bundle the group of ports as a one logical link. So the spanning tree protocol will consider it as a one link only. So when several Ether channel bundle exist between the switches, several channels now, spanning tree may block one bundle to prevent the switching loops. When STB block one of the redundant links, it blocks the entire Ether channel. Means we have two redundant Ether channel. Now STB will block one of them. All ports within that Ether channel will be blocked in this scenario. So this block will block all ports belongs to that Ether channel links, where is only one Ether link. Now all physical link on the Ether channel that are active, or they are active because the spanning tree protocol sees only one logical link. So one more time for these points. If we have two Ether channels, 10 ports pair one, spanning tree protocol will see only two logical links. So it will block one of them. And in this case, all ports within that Ether channel will be on the blocked state. Now the other one is activate in an active state. How many ports we have within that Ether channel? 10. All of these 10 ports on the active state. So we have allowed the redundancy without blocking the ports in this scenario. So Ether channel provide redundancy because overall links will be seen as a single one logical connection. Additionally, the loss of one physical link within the channel does not create a change in the topology. One port out of the 10 is down, there is no problem, will not change the topology at all. Now, we need to talk now about some implementation restriction or rules when we want to implement the Ether channel aggregation. Ether channel has a certain implementation restrictions, including the following. Now, what are the main restrictions? The interface type cannot be mixed. The port speed cannot be different. Another way, for example, fast Ethernet, gigabit Ethernet cannot be mixed together into a single Ether channel. Currently, each Ether channel can contain up to 8 compatibility configured Ethernet ports. Ether channel provide full duplex bandwidth up to 800 megabit per second for fast Ethernet or 8 gigabit per second for between the gigabit Ethernet and another switch or host. Now, Cisco Catalyst 2960 layer 2 switch currently supports up to 6 Ether channels, not ports. So, most important now points, the first one. We cannot mix different speeds together into a single bundle. Next now points, the individual Ether channel group member port configuration must be consistent on both devices on each side of the switch. If the physical ports on one side configured as a trunk, the physical port on the other side must be configured as a trunk as well. And they should be within the same native virtual VLAN. We are talking about the native and tagged traffic. Last week. Additionally to that, all ports in each Ether channel must be configured as layer 2 ports. It should not be a routing ports. So, same configuration, same VLAN, same speed, layer 2 ports. Each Ether channel has a logical port channel interface. The configuration applied to the port channel interface affects all interfaces that are assigned to that interface. Now this one actually is repeat this point. One, configure the port channel. We already applied the configuration of the port channel to the all interfaces within that port channel. Now, what's the auto negotiation protocol? Ether channel can be formed through a negotiation using two protocols. Now, the switch will negotiate with each other in order to create or form the Ether channel, usually by using one of these two protocols, port aggregation protocol, and the shortcut stands as or pronounced as BAGB protocol, port aggregation protocol, or we can use the LACP, link aggregation control protocol. These protocols allows the ports with similar characteristics to form a channel through dynamic negotiation with adjoining switches. So the switches will negotiate with each other either by using BAGB protocol, port aggregation, or link aggregation control protocol, LACP protocol. It's also possible to configure a static or unconditional Ether channel without use any of these two protocols, BAGB or LACP, let me say. Now, let us discuss the first protocol operation, bridge aggregation, port aggregation protocol. It's pronounced as BAGB. It's a Cisco protocol that aims or aids in the automatic creation of Ether channel link. When an Ether channel link is configured by using BAGB, BAGB packets are sent between the Ether channel capable ports to negotiate the forming of the channel. So simply ports will exchange BAGB packets in order to form or create the Ether channel. When BAGB identify a matched Ethernet link, it groups the link into one Ether channel. The Ether channel then is added to the spanning tree protocol as a single port. So we need to configure the Ether channel before the spanning tree, not after. Why? Because the spanning tree will consider the group of the Ethernet ports as a single one. Now, when it's enabled, BAGB also manages the Ether channel. Packets are sent every 30 seconds. BAGB checks for configuration consistency and manages link additions and failure between two switches. It ensures that when the Ether channel is created, all ports have the same type of configuration. So ports will negotiate by using BAGB port in order to form one logical Ether channel port. So on the Ether channel, it's compulsory that all ports will have same speed, duplex setting, VLAN information. Any ports modification after the creation of the channel also will change all the other channels ports. Now, let us talk about the operation now. As we have mentioned, BACB helps create the Ether channel by detecting the configuration of each site, each port site, and ensure that the links channel links can be enabled when needed. Now, in general, BACB protocol have 3 allowed modes. The port can be on the mode desirable mode or auto mode. If the port's in the on mode, this mode forces the interface to the channel without port aggregation protocol. Interfaces configured in the on mode do not exchange BACB packets. It's directly a channel without any exchanging of the BACB packets. Port, if the port in desirable mode, BACB mode places an interface in an active negotiation state. Active negotiation state in which the interface initiates the negotiation with other interface by sending BACB packets. So, desirable, I can start the negotiation by sending BACB packets to the other interface. Now, auto mode places in the interface in a passive. Passive, I will only wait for something to come to me. I will not send anything. Passive negotiation state in which the interface will only respond to the BACB packets that is received, but it will not initiate any negotiation. So on will not exchange the packets. Desirable will start the negotiation and exchange the packets. Auto, passive, will respond only and it will not initiate any negotiation. Now, keep in your mind this important comments. The modes must be compatible on each side. Means, if one side is configured to be auto mode, is that means that the other side will be an auto mode? No. If both of them auto, they will never initiate the negotiation. Compatible means they can negotiate to form the Ether channel. This is the compatibility here. So it's placed in an passive state if one of the sides is placed in the passive state. So they will wait for the other side to initiate the negotiation. But if the other side is also auto, which means the other side is also in the passive state, the other port side will never start the negotiation, so the Ether channel will not be formed at all if both sides are auto. Now, if all modes are desirable by using, if all modes are disabled, يعني بعد ساعتين بطلنا نشوفه بصراحة. If all modes are disabled by using the no comments, or if no modes is configured, then the Ether channel is disabled. There is no Ether channel at all if they are disabled. The on mode manually now places the interface in Ether channel without any negotiation. The on mode port will not send any BACB packets, no Ether channel forms, because the side that set to the on mode do not negotiate. How I know do not negotiate? It's already mentioned here. No negotiation between two switches means that there is no checking to make sure that all links in the Ether channel are terminating on the other side, or there are a BACB compatibility on the switch. Now let's simplify to you all of these scenarios here on this table. Suppose we have S1 and S2, as you see. Now we are talking about the end of each side of if S1 end in the on mode and S2 in the on. Channel establishment, yes, but they will not exchange BACB packets. If one side is on and the other side desirable or desirable auto. So desirable means it will start the negotiation or the auto, sorry. So Ether channel here, it's a passive case. Ether channel will not be established because the on mode will never exchange BACB packets. If one side desirable, the other side desirable, yes, we can start the negotiation. Desirable with auto, yes. Active with passive, actually. Auto, passive with desirable, also. Ether channel establishment, yes. Auto with auto, it will not established. Now for the LACB operation, link access control protocol, agreement control protocol, LACB is a part of IEEE 802.3 AD that allows several physical ports also to be bundled to form a single logical channel. LACB allows the switches to negotiate and automatically bundle by sending LACB packets to the other switch. It performs a function similar to the BACB with Cisco Ether channel because LACB is an IEEE standard. It can be used to facilitate Ether channel in multi-vendor environments in Cisco devices. Both protocols are supported. Now, simply same steps, similar function, similar scenario, different state or different port mode naming. We have on mode on LACB, same. The interface forces to channel without LACB. Interface will not exchange LACB packets. Now, instead of desirable state, we will call it LACB active state here. So LACB mode places a port in an active negotiation state. In this state, the port initiates the negotiation with the other part by sending LACB packets. LACB passive, the port places on the passive will only become responding ports to any LACB packets received, and it will never initiate the negotiation. Same actually as the BACB, except of what we do not have desirable port state, we have an active port state. So on, we have a channel without exchanging LACB packets. One side is on, the other one is passive. It will not establish because the on port will not exchange the LACB packets. Active with active, yes. Active and passive, yes. Passive and active, yes. Passive and passive, no. I will stop here, okay? And we'll continue, inshallah, on our office hour next Sunday, and I will record it as well next Sunday.